Problem number 3. A body has an acceleration of 3 meters per second square at 30 degree to the positive direction of an x-axis. The mass of the body is 2 kg. Find the x component and the y component of the net force acting on the body, and what is the net force in unit vector notation. So in this question, we have to answer for 3 subdivisions. Let's we answer one by one. Before that, let's write the given first, and by that we can answer the question separately, right? So what is given in the question? The acceleration of the body is a equal to 3 meter per second square, and this acceleration acting at an angle of 30 degree, that means the theta value is 30 degree, and the mass of the body here given as 2 kg. That means if you draw the diagram, this is your x-axis, this is your y-axis. So let's we take this is the acceleration vector, and the magnitude of the acceleration here they gave as 3 meter per second square, and the angle of an acceleration with respect to the positive direction of the x is theta equal to 30 degree. So that means here mass is the scalar, acceleration is the vector, right? So if you want to find the x component, so what we are going to find in the first part, we are going to find the x component of the net force, and in the B part we are going to find the y component of the net force, and third part we are going to find the vector equation in unit vector notation. So first of all, we are going to find the x component of the acceleration. That means this is your ax and this is your a of y, right? Clear? So what I'm going to do, first I'm going to find the answer for the x component of the acceleration. So x component of acceleration. First I'm going to find the x component of an acceleration. So what's the formula for finding the component? A of x, which is equal to the magnitude of a multiplied by cosine theta, right? So here the magnitude value they gave here as 3 meter per second square. So I'm going to substitute the value. So 3 multiplied by cosine of 30 degree. Here I got the answer for the x component of the acceleration as 2.598, and the unit for the acceleration is meter per second square. Likewise, I'm going to find the y component of the acceleration. So y component of an acceleration, rule is a of y, which is equal to the magnitude of a multiplied by the sine of theta. Here the magnitude of the acceleration they gave in the question as 3 meter per second square. That means 3 multiplied by a sine of 30 degree, and here I got the answer as 1.5 meter per second square. Now what I'm going to do, we can easily find the answer for the first and second part. That means the answer for a part. That means we are going to find the x component of the force. As we know the formula for the force, which is a Newton's second law, so f of x, which is equal to the mass multiplied by the x component of the acceleration, and for B part I'm going to write the formula f of y, which is equal to mass multiplied by the acceleration in y-axis. That means the y component of the acceleration. Now I'm going to substitute the value. The mass value already they gave in the question as 2 kg. So 2 multiplied by the acceleration x component here is 2.598. If I multiply this number, here I got the answer as 5.196, and the unit is Newton, right? So we can round this to 2 digits. So therefore the answer for the first part, a, f of x equal to 5.20 Newton. So this is the answer for the a part. So now if I substitute the value for the y component of the acceleration multiplied by the mass, we will get the answer for B part, right? So therefore, f of y equal to 2 multiplied by our y component of acceleration here is 1.5. So when you multiply 2 with 1.5, we got the answer here as 3 Newton, and that is the answer for the second part B. In the third part, they ask you to give the answer of the net force in unit vector notation. So therefore, the answer for the C part is given by the rule the F net force is equal to f of x I cap plus f of y j cap. So now what I'm going to do, I'm going to take the f of x and substitute here, and I'm going to substitute the value of f of y. By that, we can get the answer for the C part easily, right? So therefore, f net vector is equal to f of x value here is 5.20. So 5.20 Newton I cap plus f of y value here is 3 Newton. So 3 Newton j cap. So this is the answer for the third question, which is a C part. So this is the answer for the first three questions, A, B, and C. That's it. Thank you.